Hello everyone, welcome back to AAS Publishing. In this module we're going to cover the topical corridor of high energy phenomena and fundamental physics. So this is the icon for the corridor, and my interpretation of that is it's a compact object at the center. We've got some jets going out, we have an accretion disk around it, and then just colored red, I think, to complete the rainbow of colors for the icons. So you may have a different interpretation, but that one is mine. So I actually head up this corridor, and I've been a editor for the AAS Journal since about 2009. So it's kind of sort of an interesting question to ask, why did I become a scientific editor? Okay, so I sort of fell in love with the journals, became a journal junkie in my first year of graduate school, so that would have been 1988. So this is before NASA ADS, and I just really enjoyed tracing a line through the literature. So we'd go into the Lick library, I'd pull out some reference I found on a topic of interest to me, and I would start tracing its lineage through the journals. And I really enjoyed that a lot. But time goes on, and life goes on. You have more responsibilities, things come up, and slowly but surely over time I found myself reading the journals less and less, and I really didn't like that. And so an opportunity arose in 2009 to become a scientific editor for the journals. And I sent in an application, and it was probably the shortest job application letter I've ever written. It's 2 sentences. It's right there. And basically I claimed that I had the knowledge, experience, savvy, energy, and desire to provide quality service to the community. Ethan picked it up, and I became a scientific editor in 2009, and hopefully I am doing those things over the last 11 years or so since I've been doing this position. So this corridor includes the physics and observations of collapsed objects, neutron stars, black holes. It's sort of the genesis of the icon. Processes that produce high energy photons and particles. So this includes cosmic rays, either by themselves or as part of a broad spectrum of emission. Also covers the physics of accretion disks and jets, theoretical and observations of supernovae, and this is a case where, depending on the application, it can either go down high energy and fundamental physics corridor, or if its primary purpose is to discuss the global properties of the universe, then it will go down the galaxies and cosmology corridor, and so this is a case borderline between those two. Other relevant topics that come down this corridor include plasma, astrophysics, extreme gravity, quantum fields, particularly as they relate to equations of states or opacities, these kinds of things, emission processes, nuclear astrophysics, MHD, shocks, particle accelerations, photoionizations, high energy outflows, bursts of all wavelengths, so fast radio bursts, gamma ray burst, X-ray burst, all those come down. I also do cover the physics-focused software instrument. So if the primary purpose is a astrophysics application and a software instrument, I will cover those. Otherwise, if the purpose is mainly the software instrument itself, the tool itself, then it will go down Chris Lintott's corridor of software in laboratory astrophysics. So these are some of there are other ones that come in here, so it's sort of a catch-all. Fundamental physics sort of covers a wide range of topics. And articles in this corridor are published in the APJ or APJ supplements if they are extensive articles presenting significant new research, which is, of course, the primary metric for publication in all of the AAS journals. So that's what I had to say about this corridor. Thank you for listening, and I'll see you on the next one. Thanks. Bye-bye.